Hi students, welcome to the problem solving session on electrostatic energy and work done. This is one of the most beautiful problems I have encountered. So I hope this will open up a lot of concepts to be understood in electrostatic energy. Let us say this problem. An electrostatic field is given by E is equal to x by 2 plus 2y ax plus 2x ay volt per meter. Find the work done in moving a point charge q is equal to minus 20 microcoulomb from origin to 400, from 400 to 420, from 420 to 000. Right? So, see, after solving this problem, we will understand why it is so beautiful problem. Let us see that. First, what they have given E value. E is given by x by 2 plus 2y ax plus 2x ay volt per meter. Right, they have given that. Then q is given. Q is equal to minus 20 microcoulomb. What they asked the work done to move a charge. Work done, we know work done related with E and Q is given by W is equal to minus Q E dot dl. That is F is equal to F dot dl. F is equal to QE minus for negative charge. So okay, this is what minus QE dl. Okay, now we have to find E dot dl. Q we know, E we know, but what we don't know is dl. First we find that. For problem number 1, we have to move a charge from origin 000 to 400. That means let us see, in this problem, in all the coordinates, z-axis is 0, so it is purely moving on xy plane. So I change the axis like this. Then it is easy for us to understand. This is a typical our graph like this, xyz. So first we are moving from origin 000 to z is 0, so just ignore it. 000 to 400. So okay, 40, it's moving, right? 000 to 4. Here I have to move. Right, this is point 1, this is point 2. Right, so where I am moving along x direction. Right, so for this displacement vector, it is a Cartesian coordinate, but my charge is moving along only x direction, so there is no y and z, so I can write dl is equal to dx ax. For Cartesian coordinate, dy ay dz az will come, but we move along only x direction, so we take dx ax. Right, now we got dl. Now we substitute. EW is equal to minus Q is 20 microcoulomb, 20 into 10 power minus 6. E is given by that one x by 2, x by 2 plus 2y ax plus 2x ay. Okay, it's horrible. I write again. Fine, so W is equal to minus 20 into 10 power minus 6 into E dot dl. E is x by 2 plus 2y ax plus 2x ay dot dx ax. Fine, okay. So if you take a dot product, what will happen? Minus ay dot ax 0. So ax dot ax 1. So it will become 20 into 10 power minus 6 into x by 2 plus 2y dx only. Ax dot ax 1. Okay, now integration with respect to x-axis. So x varies from, for this problem, 0 to 4. So the limit goes from x is equal to 0 to 4, right? So minus, I take this constant outside, 20 into 10 power minus 6, 0 to 4, right? X by 2, but we have only y here, that we have to change, then only we can have integration with respect to x. See, from this problem we understand that this is the line, this is the path our charge is taking. This is equal to What is the equation for this line? This is equal to y is equal to 0 line, because everywhere y is equal to 0. The equation for this line is y is equal to 0. Wherever you go, y will be 0. So just 10th standard mathematics. So y is equal to 0. So if you substitute y is equal to 0 here, what will happen? This will become 0. So cancel, remove it, and we can make dx only, x by 2. Okay, x by 2 dx. Fine. Okay. Because y is equal to 0. Now if you integrate, what you get is my 80 microjoule, right? That's what our work done, 80 micro. This is what simple integration, x by 2 dx, right? Okay, this is what answer for first problem. Okay, so we have to, in order to move the charge from what we are doing, we are moving the charge of 20 microcoulomb from here to here. We have to do 80 microjoule of work. You see, what is the next problem? Next problem asks, we have to move the charge from 400 to 420. 400, that is 40 here. We have to move 420. It's 4y2. So we will move here. 4 to z0. That's it's a z is equal to 0 plane. That's why it is xy plane. Okay, so we have to move from here to here, right? So here you see, what is the only change which happens? Only x is changing, y is constant. It is a line parallel to y-axis, right? For that, what is the equation? X is equal to 4. Yes or no? Right? So here you see, wherever you go, x is equal to 4. This is the equation of this line is x is equal to 4, right? 10th standard mathematics, right? We will use that. So here, what is displacement? My charge moves along only y direction. So for second problem, my dl is, for problem number 2, dl is only y direction, dy ay. It's not moving along anything, and moreover x is equal to 4 in that, right? So here, what is the equation? E dot dl first we find, or otherwise we can find w is equal to minus q, and that is constant, right? E dot dl, E is given by x by 2 plus 2y, ax plus 2x ay. This is E. Dl dot dl is dy ay. Okay, so what will happen if you simplify this? Minus 20 into 10 power minus 6, right? Ax dot ay 0, so it will become 0. Only 2x dy. Okay, so I have to integrate with respect to y. What is the range of integration? Integration, my path is from y equal to 0 here to y is equal to 2. So y varies from 0 to 2. The integral goes from 0 to 2. Y varies from 0 to 2, and 2, I told x is equal to 4, right? So x is equal to 4, you can substitute dy. Now if you integrate simply, what you get is, we will get the work done to move a charge from 400 to 420 is just 320 microjoule. It's plus, right? Minus 20, so it is plus 20. Okay, so 320. And equation is minus of q, so q is minus 20, so it will become plus 20, right? So here 320 joule, here 80 joule, microjoule, right? So microjoule. Okay, now the third problem, right? For third problem, where we are moving, okay, sorry, where we are moving from, right? We are moving from 420 to origin. 420. This is 420. From here to origin, we have to move. So we are moving in this direction, right? 420 to origin. So now we have to know in which direction it is moving. We have to see all the things. Okay. So and we have to find the equation also. How the equation of this line also plays crucial role. Okay, here it is moving in x and y plane. It is not moving in z plane. So what will be our dl? dl should be only dx ax plus dy ay. There is no movement along x direction, z direction. So the charge moves from 420 to 000. So it is moving along only x and y direction, not in z direction. So dx ax dl. Now what is the equation of this line? That will also very important. Here you see it is 000 is 420. So 422 0 x and y. So for that we know we use y is equal to mx plus c formula. It is intercepting at origin, so z0. What is slope? Slope is equal to y2 minus y1 divided by x2 minus x1. y2 is 0 minus 2, 0 minus 2, x2 minus x1, 0 minus 4, that is 1 by 2. So m is equal to 1 by 2, so y is equal to 1 by 2x. This is the equation of this line, right? Okay, now we can go and solve the problem, right? Okay, what about this? Here dl is given by dx ax plus dy ay and y is equal to 1 by 2 x. This implies dy is equal to 1 by 2 dx. Now we see w is equal to minus or plus 20 into minus 6, where we have to move, okay, that we will keep later. E is given by x by 2 plus 2y ax plus 2x ay dot dx ax plus dy ay. That is giving 20 into 10 power minus 6, and this will, you see, integrate ax dot ax will be 1. So x by 2 plus 2y dx here, right? Plus I integrate, split the integration, plus here is ay dot ay, so 2x dy. Okay, this is what my integration. So 20 into 10 power minus 6, right? Here the integration with respect to x only, so we know what is y. Y is equal to 1 by 2x, so substitute that x by 2 plus x, because y is equal to x by 2. Now everything in terms of x. So where is the charge moving from? 4 to 0, 4 to 0 0. So x changes from 4 to 0. So x goes from 4 to 0, right? Plus 2x. This is this integration with respect to y. So I want everything in terms of y. What is dy? dy is equal to 1 by 2 dx. So again I can change it to dy is equal to 1 by 2 dx. Now integration again varies from 4 to 0, because the integration is with respect to x. So I convert into everything in terms of x. So dy is equal to 1 by 2 dx. Substituted that, right? So x changes from 4 to 0. Now you simplify this, what you get is work done will be minus 400 microjoule. Okay, right? So this is what work done to move a charge from 4 to 0 to 0 0 0. Now the real beauty of the problem, right? First what we did, we have moved from 0 0 0 to 4 0 0, right? So here we have moved. What happens when we move from here to here? What is the amount of work done? We have done 80 microjoule, right? So 80 microjoule of work we have done in this direction to move a charge from here. Then we moved from 400 to, we moved to 4 comma 2 comma 0. Here we have done 320 microjoule. What we did is we have moved against the field, right? When we come back, the work done is spent. How much we have spent? minus 400 microjoule. What is the total work done? You see, 80 plus 320 minus 400, work done is 0. This proves that electric field is conservative field. Right? By seeing the question itself, we can tell the answer as 0. Total not net work done is 0. Right? Here we are moving in this from, let us assume 0 A B. From 0 to B, we are moving against a field, and we came here and spend the work, and after that the energy stored will be dissipated as minus 400 microjoule. So energy is neither created nor destroyed. Right? So it's one of the wonderful problem I have seen. I hope it will be useful for you too. Thank you.